Welcome to the Bodhi Academy. My name is Amisha Plaso, and in today's video we will start with a new chapter of Thermodynamics, class 11, chapter 5. Now when we talk about thermodynamics, in this particular chapter we are going to learn certain things like the terms, that is system and surrounding. Then we will learn how to differentiate between closed, open and isolated system. We will learn about what is internal energy, work and heat. Also we will then learn about all the laws of thermodynamics. Then we will see how we can define the state functions u and h, correlate delta u and delta h, measure experimentally delta u and delta h, and so on. Now in today's video we will just start with the introductory part of thermodynamics, so as to why we are learning thermodynamics. Now previously when we talk about chemical kinetics, reactions, all of this, in this what we are doing is exactly we are trying to understand how the reaction proceeds, okay, how much it proceeds, at what rate it proceeds, how much product it is going to yield us. All these things we have discussed in the previous lessons. Now in thermodynamics we are basically going to focus on the study of the energy transformations that form the subject matter of the thermodynamics. Whatever energy is being transformed or it is getting converted from one form to another, and how it is getting converted and why it is getting converted, is what we are going to talk in terms of thermodynamics. The laws of thermodynamics, they deal with the energy changes of macroscopic systems involving a large number of molecules rather than microscopic systems containing a very few molecules. So in thermodynamics we talk about larger systems as compared to in comparison to smaller systems. In smaller systems we have very few molecules that will be interacting or reacting. So in that case we prefer to talk in terms of larger systems where we have larger number of molecules that will be interacting. Now thermodynamics, it does not tell us about the rate of the energy formations. It does not speak about how fast the transformation is happening or how slow it is, but it is basically based on the two things, initial and the final state of the system. How the system was initially at the start of the reaction, how it is at the end of the reaction, and how the system is undergoing the change. The laws of the thermodynamics apply only when a system is in equilibrium or moves from one equilibrium state to another state. So now when we are talking about the laws of thermodynamics, we need to remember that they are only applicable when the system is in equilibrium or it is moving from one state of equilibrium to another. So in between, where there is no equilibrium attained, is what we are not going to discuss. We are only going to focus on the equilibrium and the shift that happens from one equilibrium to another. Now there are some important thermodynamics terms that we need to know. So throughout this chapter we are going to keep talking about this certain terms that we need to very well know. So we are interested in chemical reactions and the energy changes accompanying them. For this we need to know some of the thermodynamics terms, and they are as follows. First, let's look at the system and the surroundings. Sorry. A system in thermodynamics, it refers to the part of the universe in which observations are made and the remaining universe constitutes the surrounding. Now say a system is basically on what the observation is being made, okay. Say you have a growing plant, okay. So what will be the major observation? You will see, first you will have a seed that you will plant, okay. Then that seed will start to germinate and it will form a small sapling. Then it will grow into a plant. So what is the main observation here? We are focused on the sapling or the seed that we had sowed in the beginning, correct? Now in that case, that observation, that seed or that sapling becomes our system, and the rest surrounding is maybe the vase or the garden where it is present. That becomes the surrounding. So surroundings include anything and everything apart from the system. So when you have to talk about the universe, we say it is the system plus the surroundings. If I am talking in terms of the example, we consider the seed or the sapling along with the vase or the garden it is present in. That together is known as the universe. However, the entire universe other than the system is not affected by the changes taking place in the system. Now when you say I have a vase in which the sapling is growing, if the sapling is growing, is there any other change that is occurring in the surroundings? No, nothing is changing, just the sapling is growing. So there is no direct effect that is happening on the surrounding of the system. Now for example, say we are studying the reaction between two substances A and B kept in a beaker. Now the beaker containing the reaction mixture is the system, and the room where the beaker is kept is the surrounding. So like that, if you have a reaction mixture, say A and B in a beaker, that becomes the system. That is where our observation relies, right? We are going to see what happens in the beaker, and the place or the room where it is placed, that becomes the surrounding. It is necessary to think of the system as separated from the surroundings by some sort of wall, which may be real or imaginary. Now when we talked about the beaker and the room, now how do we differentiate that what is the system, or up till where is the system and up till where is the surroundings? So in that case, we need to know that always it is necessary to differentiate between a system and a surrounding, we need to have a wall that may be imaginary or real. Now if we talk in terms of this beaker, okay, in here the walls of the beaker will become the imaginary wall, correct, because the beaker itself is a system. Apart from the beaker, nothing else is the system, rest everything goes into the surrounding. So the edges or the walls of the beaker itself are the wall that differentiates between the system and the surrounding. So the wall that separates the system from the surrounding is called as the boundary. So this walls of the beaker over here in this example would be known as the boundary, okay, that will differentiate between the system and the surrounding. Now there are three major types of systems. So first we have the open system, closed system and isolated system. Now in an open system, there is exchange of energy and matter between the system and the surroundings. So when we are talking about open system, say you have a cup of tea, okay, a hot cup of tea you have brought it and you have kept it on a table, okay, in a room. Now how do we look at the exchange of energy that is happening here? So if you bring a hot cup of tea and you place it in a room and leave it like that for a long period of time, say 2 hours, okay, in that case what will happen? What changes will occur? No changes will actually occur in the surroundings, but on the system when you see, because the tea is left open, what will happen? There will be exchange of energy, that is the tea will cool down. First it was hot, then it will become completely cold. So there is some kind of exchange of energy that is happening, and therefore the tea is cooling down. So that is a simple example of a open system where there is exchange of energy and matter when the system between the system and the surroundings. Next, let's look at a closed system. Now there in a closed system, we need to know there is no exchange of matter, but exchange of energy is possible between the system and the surrounding, okay. Here if we look at open system, another simple example is acetone, okay. Say I bring acetone and I leave it open over there. So what is happening? Exchange of energy is happening, and secondly matter also, because the matter is reducing, right, because acetone is highly volatile. If you leave it open, it will disappear. So here both the things are happening, exchange of energy as well as matter. But now if you have a closed system, in that there will be no exchange of matter, no loss of matter will happen, but some or the other exchange of energy will be possible between the system and the surrounding. Here we can take several examples, like a presence of reactant in a closed vessel that is conducting. Say example, copper or steel in a closed system. Now the last one is the isolated system. Now in an isolated system, there is neither happening. There is no exchange of energy as well as no exchange of matter that is occurring between the system and the surrounding. Example would be a thermos flask, okay, in which if you pour hot water, it remains hot throughout. There is no cooling happening, there is no reducing of quantity, so both the things are not happening. So that is a simple example of isolated system where neither energy is being exchanged nor the matter is being reduced. Now let's understand what are these states of a system. So now for a system to be described, in order to make an useful calculation by specifying quantitatively each of the properties such as pressure, volume and temperature as well as the composition of system, we need to describe the system by specifying it before and after the change. Okay, now some of the properties, if we have to for a system, if we want to describe how the system is on what basis, some of the simple properties that we know is volume, pressure, temperature and as well as composition. So now to know this, we have to specify what change is occurring before the reaction and after the reaction. Now to specify this, the state of the system is given by state functions or state variables. Now let's see what are the state functions or state variables. The state of a thermodynamic system is described by its measurable or macroscopic properties. As in, say there is a huge group of students, okay, all of them are wearing uniform. So what can we conclude from that? Look, just by looking at them, no other nothing about their names, age, nothing, okay, there is just a group of students wearing uniform. So what you will conclude that they are all students, okay. Why? Because they are in a huge quantity, a huge number, and they have something in common between them. What is that? They are uniform. So we can, based on that, we can justify first thing that they are students, second thing we can even know the name of their schools. So that becomes a state property, wherein based on the n number of observations that you have which are visible or which are measurable, in that case you can define the state of a thermodynamic system. We can describe the state of gas by quoting its pressure, volume, temperature, amount, etc. Now variables like PVT, pressure, volume and temperature, they are called as the state variables or state functions. Now why are they called as state variables or state functions? Because their values only depend on the state of the system and not how it is reached, okay. So in this case, we don't see how the pressure, volume, temperature has been attained, okay. We are only concerned about on what these values depend, okay, on what they are dependent on. That is the initial and final is what we need. In between, how they reached or how they decreased, that is none of our concern in this case. Therefore, they are known as state variables or state functions because their values only depend on the state of the system and not how that state has been reached over there. Now let's talk about the internal energy as a state function. Internal energy, we already know it is U or delta U, change in the internal energy. Now what is this internal energy? So when we say we have n number of energies of system, we can talk about chemical energy, electrical energy, mechanical energy, all these energies which are there. These energies together, as in the sum of all these energies together, form the internal energy of the system. And now this internal energy which is there, it can be varied or it can change depending on some of the factors like the heat passed in and out of the system, the work that is done by the system or on the system, and the matter that enters or leaves the system. So we have three things here: heat, work and matter. So heat that is going in and out, work that is being done on the system or by the system, and matter that is entering or leaving this system. So based on this, in the further class we will talk about the work done by the system, on the system, the heat and the change in matter. Okay, so this was it for today's video. I hope you have understood. Please don't forget to like, share and subscribe to the Bodhi Academy.